Alright, in this example, it says if tangent theta equals -4 and cosine theta is greater than 0, again, when it says greater than 0, then the only thing you conclude from that is cosine theta is going to be positive. The question is, find sine theta and cosine theta. So, when you're solving for this, and you're trying to use one of the Pythagorean Pythagorean identities, the only one that use tangent, because you only got the value for tangent, would be the one tangent squared theta plus 1 equals secant squared theta, which I'm going to write right here. So again, the only Pythagorean identity you're going to use is the one that has tangent or given tangent. So tangent square theta plus 1 equal secant square theta. Now, since we got a value for tangent theta, I'm going to rewrite this part as tangent theta square plus 1 equal secant theta also square. So all I did was move the exponent on the outside of the parenthesis. So that's all I did. It still means the same thing, it's just looking in different form. So what I'm going to do next is plug in the value of tangent theta into here. So tangent theta is -4, so -4 square plus 1 equal secant theta square. Alright, so here the only thing we can simplify is -4 squared, which will become a positive 16 plus 1 equal secant theta square. The only thing we can do on the left side is 16 plus 1, which will be 17 equal secant theta square. Now we're almost done. We're trying to find the value of secant theta, and the opposite of the square, if I want to get just simply secant theta, is, again, the opposite of square is square root. So I'm going to do the square root on the right side. So therefore, if I do it on the right side, I have to do it on the left side. Now when you're doing the square root of any number, there's always one thing you have to include, which is plus and minus. So when we do square root on both sides, on the left side will be plus minus square root of 17, because it was not a perfect square, equal to the square root of secant theta squared will be simply secant theta. So again, when you're doing the square root of any given number and you're simplifying, always include plus and minus, because doing the square root will give you two answers. Now, this right here plays into part of cosine theta is greater than 0. Now, we have positive square root of 17 and negative square root of 17 equal to secant theta. But that's still not going to help us find the value of cosine and sine. But going from the previous section, we covered reciprocal identities. So we know that the reciprocal identity for secant is 1 over cosine. So cosine theta is equal to 1 over secant theta, since we have the value of secant theta and we're looking for the value of cosine. keep in mind, cosine theta is greater than 0. So, let me write right here as a note. So cosine theta is positive So since it's positive, what we're going to do, ignore the negative square root of 17 and use positive square root of 17. So that's all we're going to do. So since cosine theta is positive, we're going to ignore the negative square root of 17 and just use positive square root of 17. That's all we're going to do. Again, that's all we're going to do. Because it's this given information. Just like how we cover in 4.3, you use one given information and then you use the other given information to determine if it's positive or negative. Alright, so we're going to use positive square root of 17 for secant theta. So, cosine theta is equal to 1 over the square root of 17. Now, just like in 4.1 and 4.2, we cannot have a radical in the denominator, so we're going to rationalize it. We're going to multiply top and bottom by square root of 17. So doing so, on the top, 1 times square root of 17 will be square root of 17. And on the bottom, the square root of 17 times the square root of 17, well, they're both the same number and they're both square root. It will be simply 17 on the bottom. So cosine theta will be square root of 17 over 17. Alright. Next is how we're going to find the value of sine theta. Well, just like how I use the reciprocal identity for cosine and secant, I'm going to do the same thing, but I'm going to use the quotient identity because we know the value of tangent. Now we know the value of cosine theta. So, to review, we're going to use the quotient identity since we know the value of tangent and the value of cosine theta. So, I'm going to erase to make more room. So let me write out the value of cosine theta. Alright, in order to find the value of sine theta, we're going to use the quotient identity because now we know the value of tangent and the value of cosine. So I'm going to write the quotient identity. So tangent theta is equal to sine theta over cosine theta. And since we know the value of tangent and the value of cosine, all we do is we're going to plug it in. So for tangent theta will be -4 equal, we don't know sine, so it stays the same, so sine theta over the value of cosine theta, which is square root of 17 over 17. Alright, if I want to get sine theta by itself, I'm simply going to multiply by the denominator, which is square root of 17 over 17. So, times the whole fraction, square root of 17 over 17. Multiply on the right side, therefore multiply on the left side. So, square root of 17 over 17. So on the left side, a fraction times a whole number, all you have to do is multiply the whole number to the numerator, which in this case, negative 4 times square root of 17 will simply be negative 4 square root of 17 over 17. And you can't simplify because there's nothing common between 4 and 17. Equal. Now on the right side, when you're multiplying sine theta over square root of 17 over 17 by square root of 17 over 17, these two will divide and become 1, which will leave you with sine theta on the right side. So my value for sine theta is negative 4 square root of 17 over 17. So that's all we have to do. So the value for cosine theta is square root of 17 over 17, and it is positive following this information. And then the value of sine theta is negative 4 square root of 17 over 17. So that's our answer for those two trig functions. Now, to review with this example, we use the Pythagorean identity tangent squared plus 1 equals secant squared, since it was given a value for tangent, which we got the value for secant theta. But remember, it was secant theta squared, so we did the square root and got the positive and negative square root of 17. But keep in mind, cosine theta was positive, so we used the reciprocal identity, which was cosine theta equal 1 over secant theta. Since cosine is positive, we only use the positive square root of 17 and not the negative square root of 17. Doing so it helped us find the value of cosine theta, which was square root of 17 over 17. And then after we get the value of cosine and using the value of tangent, which was negative 4, we use the quotient identity, which was tangent theta equals sine theta over cosine theta. And then we just plug in for tangent and cosine, and then simplify to get sine theta by itself, which we got sine theta equals negative 4 square root of 17 over 17. So that's basically using the Pythagorean identity, then the reciprocal identity, and now the quotient identity. So all three identities in one example.